Hello, welcome back. In today's video, we journey into the heart of rural Ukraine to see how a group of men can build an entire house in just 10 days. At this stage, they're marking the foundation layout directly on natural ground. With aerated concrete houses, precision matters. The walls are light, but the load still needs a straight, well-aligned footing. Even a few centimeters off here will affect every AAC block above. Once the layout is set, the rebar is measured and cut directly on site. This steel frame will define the strength and stability of the foundation footing. At this stage, wooden stakes are driven in to lock the four corners of the foundation. They don't carry load, they control geometry during concrete placement. With a light modular wall system, accurate corners and levels are critical for everything built above. Next, fresh concrete is poured directly into the foundation footing. A vibrator is used to remove trapped air, allowing the mix to fully surround the reinforcement. Next comes trench excavation, following the layout lines set earlier. Both width and depth are carefully controlled to ensure the concrete works evenly on natural soil. In foundations supporting light wall systems, the ground beneath is the first load-bearing element. At this stage, timber formwork is installed to lock in the foundation shape and concrete level. The formwork doesn't just hold concrete, it controls alignment and working edges of the entire base. Reinforcement is then positioned accurately to ensure proper load transfer and concrete cover. With a light block wall system, the foundation must be precise from the start, as any error carries upward into the structure above. Once the foundation layout is set, weak soil inside the footing area is excavated. This creates space for sand and crushed stone, which help distribute loads more evenly onto natural ground. For structures built with lightweight block walls, this base layer reduces differential settlement and improves overall stability. It's a quiet step, but one that defines the foundation's long-term performance. The sand and crushed stone layer is then watered and compacted using a vibrating plate. Moisture allows fine particles to fill voids, while vibration forces the base to act as a single dense layer. Proper compaction directly affects load capacity and settlement control. If this step is rushed, everything built above loses its reliability. Before pouring the foundation slab, the entire water supply, drainage system, and storage tank are positioned at their designed levels. All pipes are securely fixed to prevent movement during concrete placement. In a monolithic slab, this is a point of no return. Getting it right now ensures reliable utilities without compromising the slab or the wall system above. Next, a moisture barrier is laid across the entire foundation surface. This membrane prevents ground moisture from entering the concrete and helps retain cement water during curing. Slab reinforcement is then positioned at the correct working height, forming the load-bearing frame of the floor. Once fresh concrete is poured, the foundation becomes a single, unified mass, ready to support the block wall system above. Immediately after pouring, the foundation surface is screeded while the concrete is still workable. This process establishes the correct level and ensures even distribution of cement and aggregates. This surface sets the reference for the entire structure above. Once the foundation is dry and fully cured, wall construction begins with the first course of blocks. Aerated concrete blocks are lightweight units made by introducing air into concrete, then curing it under high pressure and heat. Their porous structure provides excellent thermal performance, but demands high accuracy at the base course. Get this first row straight and level, and the entire wall system will follow naturally. Between each block, a thin, continuous layer of AAC bonding adhesive is applied. This high-strength, low-shrinkage mortar bonds the blocks into a single, unified wall system. Unlike traditional thick mortar joints, thin bed adhesive reduces thermal bridging and geometric deviation. It's this precise joint that allows lightweight block walls to remain accurate and stable over time. At this stage, the elevation of each block is carefully checked and adjusted. Any excess material is ground down to keep the wall aligned on a single reference plane. In aerated concrete block systems, errors are not corrected with thick mortar, but directly on the block itself. This precision defines the wall's straightness, tight joints, and long-term structural performance. Once the wall reaches a certain height, continuous grooves are cut along the blocks. Steel reinforcement is placed inside these channels and bonded with mortar or adhesive. This reinforcement spreads stress, limits cracking, and improves the wall's resistance to lateral forces. In aerated concrete block construction, layered reinforcement allows the wall to act as a stable, continuous structural element. As the walls rise, window and door openings are left exactly according to the design. Edges are kept straight and square, prepared for future lintels and frames. Accurate opening layout prevents unnecessary cutting and maintains structural continuity around weak points. At window and door openings, horizontal lintels are formed and cast in place with reinforced concrete. These beams transfer loads above the opening into the adjacent walls, preventing stress concentration at the edges. Monolithic lintels add stiffness, reduce cracking, and maintain overall wall geometry. Once the lintel beams have fully cured, the timber formwork is removed. At this point, loads above the openings are safely transferred through the reinforced concrete into the walls on both sides. Additional block courses are then laid, maintaining the designed height and alignment. The wall system now begins to act as a complete structural element, ready for the next construction stage. Once the walls reach their designed height, timber formwork is installed along the top to prepare for casting the reinforced concrete ring beam. This beam ties the entire block system together and distributes roof loads evenly into the walls. In lightweight block construction, the ring beam is essential for stiffness, crack control, and long-term structural stability. To save time, the front yard slab is prepared alongside the wall ring beam. A moisture barrier is laid, reinforcement is installed, and both elements are poured in a single concrete operation. This approach reduces cold joints and improves overall construction efficiency. In lightweight block buildings, synchronized concrete work helps maintain continuity and long-term performance. Once the ring beam is completed, installation of the roof beam frame begins. A protective layer is placed between timber and concrete, providing moisture and thermal separation. This barrier prevents moisture migration from the concrete into the wood, reducing long-term decay and warping. A properly detailed roof connection is critical for durability and structural stability. This timber beam acts as a load distribution and bearing element for the entire roof system. It receives loads from the roof frame and transfers them evenly into the concrete ring beam and walls below. The timber also provides an ideal fixing surface for rafters, allowing precise anchoring compared to bare concrete. This detail improves roof stability and reduces stress concentrations. While the main structural elements are being completed, a separate crew starts building the interior partition walls. These walls are non-load-bearing, but they define spaces and functional zones inside the house. Using aerated concrete blocks allows faster construction, lower floor loads, and flexible layout adjustments. Even for partitions, alignment and bonding must be carefully controlled to ensure long-term stability. Next comes the installation of the roof joist system, laid in parallel to distribute loads evenly. These joists carry forces from the roof layers above and transfer them into the timber beam and concrete ring beam below. Spacing is carefully calculated to prevent deflection and twisting under wind, snow, or service loads. Roof joists ensure stable load distribution without overstressing the walls. Once the joist system is secure, the roof frame is erected piece by piece. Each truss is positioned according to design, ensuring proper roof pitch and load distribution. The roof structure must carry its own weight while resisting lateral forces from wind and snow. Accuracy at this stage directly defines the building's long-term durability and structural safety. With the roof frame secured, sheathing panels and technical membranes are installed on top of the trusses. Timber battens lock the layers in place, while creating ventilation gaps beneath the roof covering. This assembly forms the working base for the final roof system and controls moisture and wind intrusion. Precision at this stage ensures a dry, durable, and long-lasting roof structure. Next comes the installation of timber roof sheathing, forming the structural skin of the roof. Panels are staggered and securely fixed to the joist system, ensuring even load distribution and overall rigidity. This layer provides both structural support and a solid base for waterproofing and final roofing materials. While the roof work continues, interior crews begin plastering walls and installing doors. The plaster layer protects the block surface, improves airtightness, and prepares the walls for final finishes. Doors are installed at correct levels with proper clearances for insulation, sealing, and smooth operation. At this stage, the building starts to transition from structure to livable space. Before the final roofing layer is installed, all corners and roof joints are carefully waterproofed. Membranes are overlapped and sealed to protect the most vulnerable points of the roof. These areas are where leaks usually start if details are neglected. Finally, the finished roofing layer is installed over the prepared structure. At this point, every layer beneath, sheathing, membranes, and drainage paths, begins working as one system. The roof does more than block rain. It protects the entire structure from moisture and long-term deformation. A reliable roof is defined not by the final covering, but by the precision of everything built before it. Next comes the floor installation once the structure is fully protected from the elements. Floor panels are set into a dedicated adhesive layer, ensuring level placement and strong bonding to the concrete slab below. Joints and expansion gaps are carefully controlled to prevent cracking or buckling over time. During floor installation, a leveling clip system is used to control height differences between tiles. These clips keep the surface perfectly flat while the adhesive cures, preventing edge lippage later on. On a monolithic concrete slab, floor flatness directly affects comfort and long-term finish quality. It's a small detail, but one that defines the interior experience. If you like this video, please like and subscribe to our channel to support us. Once the tile adhesive has cured, the joints are filled with specialized grout. This layer completes the finish while sealing out moisture, dust, and movement between tiles. Even, well-packed joints allow the floor to perform consistently under thermal and load changes. It's the final step, but one that defines the durability of the entire floor surface. Once the house itself is complete, attention shifts to the surrounding landscape. Trees and plants are placed deliberately, providing shade, wind protection, and environmental balance. The soil is reworked to ensure proper drainage and long-term root stability. Before final landscaping, an automatic irrigation system is installed underground. Pipes are laid according to planting zones, ensuring even water distribution and minimal loss. Installing the system early protects it from mechanical damage and weather exposure. This approach supports healthy plant growth while reducing long-term maintenance effort. Once all underground systems are in place, turf is laid evenly across the yard. The soil base is leveled and enriched to help the grass root quickly and grow uniformly. Beyond aesthetics, turf retains surface moisture, reduces erosion, and moderates the microclimate around the house. This final step allows the building to fully blend into its natural surroundings. Finally, the porch and front yard are finished with exterior paving tiles. The base is carefully prepared to ensure proper drainage and long-term load resistance. These surfaces provide clean access while protecting the wall base and linking the house to its landscape. At this point, the project is complete, both functionally and visually. From the first foundation lines to a finished home integrated with its surroundings, this has been a journey of engineering, discipline, and hands-on experience. Every material choice matters, and every construction step shapes how the building performs over time. A good house isn't the one built fastest, it's the one built right from the start. If you found value in this process, like the video, subscribe to the channel, and join us on the next build. Thank you for watching.